Assalamu alaikum. So this video is the second part of the calculus video, the differential calculus. In the last video we talked about finding the differential and finding the gradient of the tangent to the curve of a curve graph and finding the equation of the tangent to the curve. Now here we are going to discuss the minima and maxima. What's the minima and maxima? First, uh, until now what we have done is use the curve graphs, the square, the cubed graphs, and graph of like having square terms in it. For example, we were using y is equal to x square plus 2x plus 3, something like that. So in such equations the power were like x square, and now what we are going to do is use cubic equations. Cubic equations are like expressions are like having something like this, terms like this: ax cubed plus bx squared plus cx plus d. So an equation or an expression that has the term having 3 as its power, so that means it's a cubic power, it's a cubic thing, and this expression will also be called the cubic expression. Now the cubic expressions will have graphs like slopey graph having slopes like this. Usually the square, for example y is equal to x squared, is a graph like this, having a curve, a single curve. But cubic curves are like having one upper curve, upward, and then downward curve. So any graph that has a cubic term in it will most probably be shaped like this, and the point, this point, and this point. You can see if you draw a tangent in these points, it will be exactly horizontal like this. That means the gradient will be 0. There is no slope, there is no slide on these points, and we call them stationary points. Stationary points. And the maximum stationary point will be the one on the upper curve, the tangent, the slope of the tangent, and that of the lower curve will be the lower stationary point, which is called the minimum. So to find the maximum and the minimum, we have to use differential calculus again. Now what we have to do is we'll use examples for that. Now let's say we have the equation y is equal to x cubed minus 3x squared plus 1. This equation will give us a graph like this. And again, the stationary points are the points on the graph where the gradient is exactly 0. So if we are told to find the stationary points of this graph, obviously we have to find the gradient equation and equate it to 0, and because the gradient is obviously exactly 0 at the stationary points only, and that will give us two values of x, so it will be either the coordinate x coordinate of this point or of that point. Then we'll use that to find y value of that coordinate using the equation, and if that y value is a higher value than the other, then it will be the maxima, the top stationary point, and if it's the lower one, then it will be the minima. So let's do it. Okay, so first we have to differentiate this equation. X squared, so the power will be difference of y, differentiation y with respect to x is, so first we have x raised to power 3, so the power will be multiplied by the coefficient, which is 1, and then it will reduce by 1 itself, become 3x2, 3x times 3x raised to power 2. Then we have 3x2, again here the power will multiply with the coefficient, 2 6 through 3 are 6, and power will reduce by 1, 3 became 2, and therefore this 2 will become 1, so the power of the variable reduces by 1, and for 1 we don't need to write, and 1x plus 1 has nothing, so we give it the variable of x raised to power 0, because any number raised to power 0 is 1. So again, this multiplies by 1 will give us 0 times 1, which means 0. So there is nothing that comes over here. There's no need to write anything over here because it's 0 plus 0. Now this is the equation of the gradient we have found for this graph. What we have to do is equate this to 0, because in the stationary point the gradient is 0, this and the above one. That means 3x square minus 6x equals to 0. We'll use this equation to find the values of x. What do we get? Let's factorize this. Whatever method of factorization you use, if it's a difficult one, we can't find it using the completing the square method or the other method, like the product in sum method or the simple factorization, then you will have to use the quadratic formula. But this is a simple equation, simple example. So let's factorize. Let's take the common x out on the 3. So it's 3x raised to power, so x raised to power 2, that means 1x for this term, and 3x times 2 gives us 6x, and that is of negative, so we'll put minus 2 is equal to 0. Now we have two things. Now 3x times x raised to x minus 2 bracketed is equal to 0. That means this number or this number 1 has to be 0, because the answer is 0, because any number times 0 is 0. So that means either 3x is equal to 0 or x minus 2 is equal to 0. And what do we get? If we divide both sides by 3, we get x is equal to 0 for this example, or x is minus 2. Minus 2 is, once it goes to the right side, will become plus 2. So for this, x will be plus 2. So until now what we have found is that the values of x coordinates on the maxima and the minima is either x is equal to 0 or x is equal to plus 2. Now it will be something like the x for x value and y value in a coordinate. So for this point it will be 0 and y value, and for this point it will be the coordinate of the stationary point will be 2 and y value. Now we have to find the respective y values. For that we have to look at the first equation, the equation of the graph, that what is the value of y when the x value is 0. And the first equation is x cube minus 3x square plus 1. So that means x cube minus 3x square plus 1. This is this equation, and y is equal to x cube minus 3x square plus 1. So we have to find the value of y, and we know that in this stationary point the value of x is 0. So this will become 0. 0 raised to power 3 is 0 minus, so this x again becomes 0. So 0 raised to power 2 is 0 times 3, 0 0 times any number 0, again 0 minus 0, and this is no value of x over here. You get plus 1. So the answer 0 minus 0 plus 1 is 1. So here the value should be 1. So that means we got the coordinate of one value, which is 1. So one of the coordinates is x value 0 and y value 1. 0 1. Now we have to find the other stationary point, and then we'll make sure which one is maxima, which one is minima. Again we'll use this equation, y, the equation of the graph, y is equal to x cube minus 3x square plus 1. So the value of y when the x value is 2, to be found using this equation. Y is equal to x cubed. Now x value is 2, so 2 cubed is 8. Okay, minus x square when x is 2, x the 2 raised to power 2 is 4, and 4 times 3 is 12, and then we have plus 1. So 8 minus 12 is minus 4, and then we have plus 1, and minus 4 plus 1 is minus 3. So that means we got the value for y when x is 2, and that is equal to minus 3. Now we have found the values of both the minima and the maxima. Now when we look at the y coordinates of both coordinates, y value of both coordinates, one is 1 and the other is minus 3. One is plus 1, the other is minus 3. So obviously when we have a graph like this, we have the maximum point and the minimum point, and we know that y values decide the point, how much it is like the vertical points are decided by the y values. So obviously the positive value will be the maximum point, therefore this coordinate will be the maxima and this coordinate will be the minimum. That means we have found the coordinates of the maxima and the minima. This is for the the maxima, because y value is greater than the other coordinate. This is one for minima. For the graph and the equation which was given. So maxima is 0, 1, and minima is 2, minus 3. So this point is 0, 1, and this minima point is 2, comma, and minus 3 for y. And now this is how we find the maxima and minima of equations which give us a graph like upward and downward curve, which are usually the cubic curves. So that's how we find stationary points, the minima and the maxima. Thank you.